we're going to plug our x and y in to both equations. So we're going to take x and y, put it there, put it there, put it there, put it there. If it makes the statement true, then it's a solution. If it doesn't make it true, then it's not a solution. So literally right now, take x and plug it in. Now remember, we're on the side that says notes on it, just FYI, because this not keep track at home. So 6 times 1/2, second, plus 2 times 4 equals 11. Yes, ma'am.
I see what you're doing. Do we have like bigger? You know how Mr. Harper has his like little blown up a little more? We got like blown up a little.
Take it under consideration.
Are you
What do you blown up a little bit more?
6 times 1/2. What's half 6?
3.
3.
That is wrong. That is not a solution.
Plus 8. 3 plus 8 is
11.
And that's awkward words. Cool.
That's awkward, mister.
Okay, next one. 4
So you
equals, I'm moving on,
-4
times,
half
yep,
plus 6.
well done.
So -4 times half is -2.
Mhm.
Plus 6 is equal to 4.
So, is it a solution?
Yeah.
Yes, it is.
So we're just basically finding.
Oh, my neck. Well, yeah. There's a lot of stuff we're going to be covering today. This is all a review of Algebra 1. Okay, next thing. There are 3 different types of situations we have when we have systems of equations. First one is they intersect one time. Picture of 2 lines that intersect one time. That is one solution.
Oh, wait, what happened? Oh, with the
Intersect one time.
intersect the y-axis or?
Intersect 2 lines. We have 2 different lines here, people.
The center is the solution.
Yes, sir. 2 lines that are parallel, they never intersect. So I'm going to draw 2 lines
Except they don't.
that are parallel. Right. No solution. And then lastly, 2 lines that are exactly the same. They're called coincident. They're right on top of each other. The bold part is something that I wrote in. It's not on your paper. So they are infinitely many solutions. Infinitely many solutions. Or cleverly abbreviated IMS. Yes, ma'am.
Do you have any colored pencils?
I do not. Well, I do.
Frankie.
Is this it?
Thanks.
Okay, so for 2, 3, and 4, all we're trying to figure out is how many solutions they have. Eventually, we'll get to figuring out what the solution is. I'll get at number 1. But first, we just want to figure out how many solutions there are. So hopefully, by just looking at the equations, we can tell. So on the second part, here, if I multiply everything times 3, let's do that. So I get 3x. What happens with the 3 in the denominator and all that?
It cancels out.
Yeah, it cancels out. And I get 22. Correction, all right.
So say y.
Are they the same thing?
Yes.
So if they're the same line, that means, yeah, infinitely many solutions or IMS.
How do you know if it's on the same line?
Did you also write in all root numbers?
You could, I suppose. Infinitely many solutions being an x and a y. All real numbers just kind of means one number.
But
That's okay. I'll take it.
So if you get an X and a Y, can you have IMS?
Alright, hold on. I don't know what you mean by that. When we have the same exact equation, look here. 3x plus 7y equals 22. 3x plus 7y equals 22. That's the same thing. It's infinitely many. Alright?
Oh, okay.
Okay, so the next one. If I solve the bottom one for y, what should I do first? Move y or move the x?
Move it.
Move the x. So 2y equals negative 5x minus 8. Is y by itself yet?
You guys divide by 2.
Divide each piece.
By 2, yo.
The negative 5 minus 8 equals divided by 2.
Negative 5 times x minus 4, right?
Yeah.
So I got that equation, and I have my first equation.
But that's not the same.
They're going to be
Okay,
parallel.
they're not the same. So that means they're not infinitely many. They are parallel because they have the same slope. So that would mean
Now you ain't got no solution.
So
no solution.
oh,
Okay, number 4. If I don't have any of the same numbers, and it stands to reason that we probably have an example of each one.
So you talk about.
We're gonna solve for y on both of them. Well, let's just do one though. Top and bottom, which one do you do?
Top.
Top and bottom. So move x over to negative 3x plus 9. Divide everything by negative 7. Y equals 3 7x minus 9 7. Something really ugly. Alright, if I were to solve the other one for y, if I solve this negative 2x minus 4y equals 1, if I solve that for y, am I going to get 3 sevenths? No, I'm not. Am I going to get 9 sevenths? No, I'm not. So that means they're different, so they intersect just one time. So my solution is just one solution. That's all we're doing. In a second, we'll actually figure out what the solution is with some prettier numbers, not with something like that. Okay, the next couple. Let me go back. Number 5, I want you to figure out whether that solution is, or whether those ordered pairs is a solution. So what should we do with that? Plug them in, right?
Yep.
We just did that on number 1. Go ahead and give it a shot. Number 5. Plug and shove. You sure we're putting X in the right spot, Brad? You paying attention, man?
What do we do with the 18 and the 30?
You still use it. So looking at even the first one, does 3 and negative 10, does that make it work?
No.
No, so I'm going to have to do the second one. So is that a solution? No, it's not.
Oh.
Yeah. Because 4 times 3 is 12, negative 6 times negative 10 is 60, 12 plus 60,
70.
and 18.
Now, doing on all solutions.
So it's no. You only have to do the second one. If you want to, it ain't going to work for that one either. So it's no.
You can do it for the double check.
You can do it, double check.
Because
Does make it work for you.
Yeah. All right, number 6. This is probably the, yes ma'am.
okay, so say that number 5, say that the first one did work,
Then you have to do the second one.
and then but the second one doesn't work. Is
That doesn't work.
It's still a no solution.
Gotta work
or
for
the
both of
solution
them.
solution?
If the solution doesn't work for both of them, the answer is no, that particular number is not a solution.
Okay.
Doesn't necessarily mean there's not a solution, it just means that one's not. On this one. Well, here we're looking for what x value do the both lines have the same y value.
Okay. But, 3.
What x value do both lines have the same y value? 3 over 2. So that means my answer is 3 over 2, comma, negative 5 halves. Mario, question.
Hey, Mr. Bankley, before I get left behind,
Yes, sir.
can you go over it again, like this one?
This one?
Or like just like this concept from number 5 to number 6?
Number 5, we're seeing if that particular ordered pair they gave us was true or not, whether it made this false statements work.
So do we have to go through each one they give us that?
What?
We have to attempt each one?
No. On this one, they gave us all the values, so what we have to see is where are they the same. So at 3 halves, they're the same, negative 5 halves for both of them. Okay?
And the top one is like when we were just doing what we did after the first one.
Yeah. Okay, number 7, graphing. Do I know how to graph something without it being in y equals? No. So let's get in y equals.
So minus 4x.
Minus 4x. And then how do I get that y all the length, right?
Divide by 2.
You're good,
Divide by
very
2.
good.
That'd be fine.
Is my second equation, is that solved for y? No, so what I can do to y myself? Add x. Now I love myself?
Yep.
Now I can graph them. Now this is a review of graphing lines. We're going to do this. So if I graph my first one first, -2x was 3, where do I start? Start at 3. Good. 3, go down 2 over 1. Down 2 over 1. Down 2 over 1. Since we're all wearing our IDs, we can be sure that we draw a very, very, very straight line.
Where's yours, Frankie?
That's how the Japanese
You wanna
one
use
is.
it?
Wait, where's 3?
Okay, what's my other one? Start at 3.
So we just, for this one, we just get Y and we graph it. Is it that easy? No, like,
All side combos need to stop, please. So where do both of my lines intersect? Same point. Okay, when you say 3, give me an order pair. 0, 3. 3 is there. Or -3 is there. -3 is there. You give me an order pair, you tell me exactly where it is. 0, 3. Yeah, Tyler.
Alright, Bradley. No, it's the 0,3.
Pressing on. We can not talk every time I'm not talking. Number 8. How do I get Y by itself?
Subtract.
Subtract. 2y equals -x minus 4.
We have number 8 on here.
So divided by 2 now.
Divided by 2. So y equals, now here,
-2x.
we might want to say -1/2x.
Why?
Because I don't know how to graph x over 2, but I know how to graph 1/2x.
Oh.
That's up 1 over 2.
It is the same thing, x over 2.
It is the same thing, but graphing wise, it'd be helpful.
I get
Yeah. The second one, be careful when you're solving for y. I get -y equals -x plus 5. I don't like -y though.
What you do is you gotta divide it by negative, so you
Good.
make y positive, you make x positive, and you make 5 negative.
Well done. I'm gonna start with that one since I'm using that color. My y-intercept, my b is at 5. And what's my slope, Morgan?
On which one?
On this one right here.
It's up one over one?
Over one, and up one. Good job. That's pretty shakalaka.
Mister, I don't like our graphs. For real.
Yeah, it didn't really turn out too well, huh?
Hold on.
Oh, wait on.
They're not too
Bring it back.
I tried to do it, but like,
Just
Okay.
mixing lines with your IDs.
Where do I start for my other graph? Mario? -2.
-2. You guys can go.
Yeah, well, the negative, Arturo, means what?
Oh, you go the other way.
No, yeah, like go down. Up, down 1.
So this is one solution, right?
Yes, sir.
Alright.
The same as going down to the right, being up and to the left, so I go this way a little bit. And I'm connecting my lines.
and they crosses at -2.
Yes, sir.
I mean, -3.
Order pair. 2, comma, -3. Intersect right there. Gotta give the order pair. If you don't know how to write order pairs, do the ring. Do the ring. But we had much graphing. Go, let's get 9. Let's talk about substitution property. In sports, what happens when you substitute someone in and out?
They get mad.
They get mad, good, yeah. Can you substitute someone out without putting someone else in? No. It's the same thing. I'm going to move X out, and I'm going to put what in its place?
Wait, mister. I forgot, when do we know when we gotta use substitution?
When the paper tells us.
Oh, negative three.
Oh, yeah, that's it.
-3, I'm substituting it in. Thank you for the answer. So y equals 2 times -3 minus 5. We're substituting -3 in for x. So then I'm just going to simply add. Or sorry, multiply that. Yeah, -11. Good. We got 3 different ways. There's actually more than that, but we'll talk about 3 or 4 different ways to solve these systems. One way, I've already said it like 3 times, is substitution. Elimination is another one we'll go over tomorrow. Wrapping is another one. Using matrices we'll go over, which is real fun with calculator, all that stuff. Let's go over this. Stop. We solved one of them for y. That says step 1, solve one equation for x or y. Doesn't matter which one we do. On this one, we solve the bottom one for y. Step 2 says to substitute that one in for what we know y to be.
Oh, okay, so.
Then I hippity hoppity, shooter coppity, combine like terms, blah 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 blah.
Wait, so you say y or x?
They substituted what they knew y to be,
Oh,
6 and 7 in for this one.
so.
So
Right
why?
here.
Oh, I get it.
Where's y at?
He's dragging it.
Why?
Y is right here.
Y equals 2x.
We're cutting
Plus 7.
and pasting. Alright, cool. Distribute, add like terms, divide, you get -5. That's only halfway though. That's only 1/4 pair. So then I take this -5, put it in right there. Multiply, add, do all that we just did. Let's try this, shall we?
Sure.
Yeah. Pick 2 problems, we'll do them. Let's get the other 2.
10, 13, oh. No.
10,
12,
13.
12.
12 and 13.
12 and 13?
Yeah. Right? Yes. That's the point, though.
Alright, number 12 it is. Move 9x to the side, so y equals 9x plus 1.
Nobody said 12.
Slow down.
Y equals.
Now we just plug it in right.
Step 1. Step 1 is solve one of them for x, y. Solve the bottom one for y. Step 2 says to plug it in, substitute. So 2
What year? Substitute the Y.
plug what we just solved for.
You have to make
Substitute it in
you
for
have
the
to
Y.
make- Yeah.
Where the y in the top one, yeah.
So the Y.
9x plus 1.
Yeah.
We solved the bottom one. 4, 1. So I move 9x over, I get 9x plus 1. Now I'm in the top one. I'm taking this y out, and I'm substituting this in.
Oh, for that whole Y?
Yup.
Oh, okay.
Next thing I do, distribute. Fractions are ugly.
Yes, they are.
2/3 x plus 1/3 of 9.
3.
Good. 1/3 times 1 is 1/3. Here I'm going to suggest we get rid of the denominator. Unless you, I'm multiplying every single thing by 3.
So
Sir.
that means
6x.
Yes, sir.
All
so
cancel
this
out.
is X plus 9
Nope.
X.
The 3's cancel out.
Oh, yeah.
Remember, you distribute every single time. The reason why we're
2x.
so 2x.
So all the 3's cancel?
No, just the denominators.
That's what.
Sorry. Should say that. Plus 9x.
Plus 3.
Oh, hold on, brother.
No,
Where'd you get the 3 from?
Hold on, brother.
Equals 6. I got a 3 because I saw the denominator was a 3, so I want to get rid of it.
Oh,
so I
okay.
multiply.
No. Oh, you fucked over it, man.
Oh, I do the
Yeah, turn around like that. Okay, that's what's about.
11x plus 1 equals 6.
So you add those together?
Yeah. Come on, like terms. Move 1 over.
So you, would you subtract 1?
Can you go over number 11?
So 11x equals to 5?
Yep.
And then you divide by 11?
Yep. Okay. I just got x, but I want an ordered pair. I got 5 over 11, comma, I need something else.
So you substitute now in the x, right?
Right.
No, we use our x.
Let's plug 5 11ths in right there. So 9 times 5 11ths
So you don't do it for,
You can do either one.
oh, so you can do it for the top one? Okay.
That equals y. So y equals, that's going to be 45 elevenths. Multiply the top. Multiply the bottoms.
11.
Plus 11 over 11. Because if I want to find a common denominator, it's 11.
And what, 66 over 11?
56.
Oh,
So we need help with fractions coming to tutoring.
So those are our coordinates now.
That's the coordinate where they intersect.
And that's your answer, right?
That's it. That's it.
We don't simplify 56 over.
You could write it as a mixed number. I would say like that.
If it's us to grab it,
Question.
so it's gonna be the,
Yes.
the 2x, right?
Yes.
That's your answer.
Okay, so on this, whenever we do it, are both of the denominators the same? We have to figure out what the answer or not.
More than likely, yeah.
We don't have to do
I mean, not always, but more than likely, yeah.
Conceal bruises?
Let's do it a little easier one.
Conceal bruises?
So we can pick either one, right?
Yeah. I'm almost done. Your world, you can pick the top one or the bottom one.
Top.
Top one it is. Solve for y, so I add what to both sides?
3.
Wait,
No.
4.
Wait.
I have y to both sides.
Yes, sir. We added 4. Why do we add 4?
Oh, yeah.
That's how you
It's
do
like
it.
y by itself, right?
Yeah, because you want to keep the positive.
So now,
So now you substitute it in, right?
Yeah, you put y by
So
itself.
5x
Oh.
plus 2.
Three plus 4 for y.
And 3 just equals
what?
How do you, but you don't do,
No distributing.
distributing.
So what do you do?
Now I'm just going to add 4 and 6, and 4 2 and 6.
so 3x plus 6.
That goes against, that's 4 and 2?
Well, we don't have anything to multiply by. We can't add 3x and 4.
You just skip that step.
So now do you do,
Now I'm going to pull my x on one side.
so you do minus 3?
Sorry, my
No,
So you
plus
do minus 3.
Minus 3x.
Then just take that part.
So it's 2x equal to 6. And what I said.
So I got x is 3. Am I done?
No.
I'm not fully done. We got all that
The
finished.
other one.
I got a
Here we go. Real quick. Real quick. What's 3 times 3 plus 4?
plus 4 equals
9, 12.
13.
Boom, done.
Oh.
Yeah, 12.
Extra.